So I'll backtrack to the one that I skipped, which was number 9. You should hopefully be aware of this little format right here at this point. So if I have s of t equals 6t over the sine of t, and I want to find all the vertical asymptotes. Okay, so now go back and remember that this is a format right here, whereas if you were taking the limit as t approaches 0 of this thing, you would end up with it being 6. Okay, because remember it's the coefficients, so that would be 6. So what we have here is there's an infinite number of asymptotes, because there's an infinite number of places where the sine of some random angle equals 0. But there's one place where that's not included, and that's going to be at 0, okay, because that's the special case. So when we do this, where does sine equal 0? So sine equals 0, because remember you're going to take your denominator, set it equals 0. So what values of t will get me to have a sine ratio of 0? So that's going to happen at 0, and at pi, and at 2 pi, and at 3 pi, and oh, by the way, all of these can be positive and negative. So we have all of this, but remember, we're not going to include the 0 because of the special case. So basically, we have integer multiples of pi. So remember, an integer is a counting number, either positive or negative. So this says, tell me all your vertical asymptotes. So it says use n as an arbitrary integer. So arbitrary just means I grab it because I can. Okay, and that's if necessary. If an answer doesn't exist, whatever. All right, so first of all, remember your variable. Okay, so my integer is going to be n, and I want that to be multiples of pi. But what's the one value that's going to mess this whole thing up? That's if n is 0. So as long as n does not equal 0, then you're fine. Okay, so remember this, because that's going to be popping up a lot, where we have arbitrary integers. All right, so let's do another one. We have find the one-sided limit if it exists. So I'm just taking a limit. If I use direct substitution, I'm going to get a negative 9 over 0. So I know this thing is either going to go to negative infinity or it's going to go to positive infinity. Those are my two options, okay? Because direct substitution will make my denominator equal 0. I just got to figure out which one it is. My numerator is negative all day long. And then what happens is I shove in values. I don't care what they are. You're going to square them. So anything squared is going to be what? Positive. Okay? So we've already determined it's going to go either to positive or negative infinity, because my denominator will get infinitely small, which means the expression will get infinitely large. Well, now which one is it going to be? Well, if I've always got a negative over a positive, that's going to yield me a negative answer. So my one-sided limit is going to be from negative infinity. Now, again, this says find the one-sided limit if it exists. You may have to watch that one. It should be negative infinity, but in case that's wrong, you have a D any. All right, so do it again. I want to use direct substitution if I can. So I'm going to come at 1. So 1 squared is 1. 1 squared is 1 plus 6. So nothing magical happened. Your limit's 1/7. Okay? What about if I come at negative, you can't see. What happens if I come at negative 5 from the left? So use direct substitution. So negative 5 squared means negative 5 times negative 5, so that's 25. Plus 4 over, if you use direct substitution, it's going to go to 0. So you have infinitely small denominator, which makes for an infinitely large expression. The question is, what is it going to be, positive infinity or is it going to be negative infinity? So if I'm coming at negative 5 from the left, that means I'm using negative numbers to the left of negative 5. So if you think about negative 5 on a number line, I'm using these ones over here. So if I use a negative 5.1, then negative 5.1 plus 5 is negative. Okay? Negative 5.01 plus 5 is negative. Negative 5.001 plus 5 is negative. So that's going to be negative, positive. So this term is going to go to negative infinity. So what is 25 minus infinity? Well, who cares about 25? It's just going to be negative infinity. Okay, so just reason your way through. I'm making my hand wobble. Reason your way through to determine which one it is. All right, find your one-sided limit. So I've got 1/2 coming from the positive side. So I have 8 times 1/2 squared times the tangent of pi times 1/2, which is pi over 2. Okay, so 1/2 squared is 1/4 times 8 is going to be 2. And then I've got the tangent of pi over 2. Well, the tangent of pi over 2 is undefined. Okay, so I need to realize if I'm coming at 1/2 from the bigger side, from the positive side, that means that I'm going to be shoving in values that are closer and closer and closer to 1/2, but are bigger than 1/2. So the question is, what is that going to be? So look at, hang on, make sure I'm in radians. Because I'm going through all this because people get fuzzy on trig. All right, so I have 2, what is it? I've lost it. All right, so 1/2 times pi. All right, so I have this, which is going to be stupid. It's a stupid point. Hang on. Land at Goshen. All right, I have tangent times 1/2. All right, that's just going to be x. No, never. Just forget it. Heavens to Betsy. It's going to be coming from the positive side, which means if you look at the graph, which is what I'm trying to draw for you, it looks like this. Okay, so as I come at it, if this is pi over 2, okay, if I come at it from the positive side, this is going to be going to negative infinity. That's what I'm trying to show you on the stupid graphic calculator. So 2 times negative infinity is going to be negative infinity. Okay, so he's going to negative infinity. All right, so the last one, you're going to do this multiple times. You're going to find a pattern. So again, what we want to do is I'm going to take the limit as x goes to 0 from the positive side, and then again and again and again all the way down. And my thing didn't print off all the way, but basically I'm going to show you the first one. So I am confidently going to enter this in my calculator. So x sine of x over, and then I have an x, and then I'm going to go to my table, and if you'll notice, all of these are the same. Okay, so I should be able to just enter this the whole way down. So I've got a 1, I've got a 0.5, I've got a 0.2, I got a 0.1, I've got a 0.01, I got a 0.001, and I bet the last one is 0.0001. Okay, so what do you have? What you have is those numbers right there. First of all, what does that little e mean? It means you've got, this is basically scientific notation. So you've got 1.7 times 10 to the negative 5. So these numbers are getting infinitely small, but they are still positive. Okay, so they're getting infinitely small, but still positive. Now, when you do this one, you're going to simply go back in here to your y equals, and you can just re-edit. So this is now going to be x squared. Oops, see, that was bad. I need to learn how to work this thing. All right, so that's a 2, and that's an x. So now as I hit, I don't want to grab it. I'm having issues. All right, so as I go, hang on. All right, hit the table. And now all of my values have changed, okay? So you really only have to enter this one time. The question at the end, that I'm not going to answer for you, is going to be what's the value of the limit when the power of x in the denominator is greater than 3? Okay, so in other words, you're starting off with an x to the first up here. Then you're going to an x squared. Then you're going to an x to the third. Then you're going to an x to the fourth. And a pattern is going to emerge. So you want to tell me what happens between parts C and D. So as soon as that denominator gets bigger than 3, what happens? Okay, so it's either going to go to 0, or it's going to be to negative infinity or positive infinity. And that's going to be your answer. But I'm not going to tell you. All right, so here we go. We have a 25-foot ladder is leaning against a house. And it's shown in the figure below. All right, if the base of the ladder is pulled away from the house at a rate of 2 feet per second. So let's go back to section 1.1 for a second. This is being pulled away at a constant rate of change. It is 2 feet per second, period. So this is something mechanical. Okay, so like a winch on a tow truck, something, I don't know. All right, but that is being pulled away at 2 feet per second. The top of the ladder is going to move down the wall at a rate given by the following equation, which is down here. where x is the distance between the base of the ladder and the house, and r is the rate in feet per second. So this distance right here is going to be growing larger, and I want to know what's going to happen to the rate of the fall of the top of the ladder. So all you're going to do is sub in. Okay, so find the rate of r when x is 15 feet. So if I shove in a 15, 2 times 15 is 30, over 625 minus 15 squared is going to be 225. So I get 30 over the square root of 400, which is going to be 20. So I get 30 over 20, which is 3/2. So it's going 1.5 feet per second when the base of the ladder is 15 feet away from the house. Okay, so that's 3/2. What about when x is further away than that? So now I've got 2 times 24 is 48 over 625 minus 24 squared is 576. And that's going to give me 49. So the square root of 49 is 7, so I get 48/7. So when it was closer to the base of the house, it was dropping at 1.5 feet. When it's further away from the base of the house, it's almost 7 feet per second that it's dropping. Okay, so 1.5 feet is slower than almost 7 feet per second. So can you give me a conjecture on what's going to happen as the limit of r as x approaches 25 from the left? It can't fall any further than 25 feet because that's the height of the ladder. But basically, as this base gets further away and x grows to 25, how fast is the top of the ladder moving? Okay, so I'll give you a hint. It's either positive or negative infinity, because that ladder is going to start dropping. The equation doesn't know that the ground is in the way. Okay, so anyway, well, I'll just tell you what it is. All right, so I have, it's going to be positive infinity, because the further away the base of the ladder goes, the faster the thing goes. So you are now ready to do your chapter 1 review and then take your chapter 1 test.